Thank you very much, Maria. Hi, I'm Clemens. And I have a problem because my coffee is almost empty. How did that happen? It's like the first webinar where that happens. Right. Anyway, today, 5-minute IDP, which means I am having a problem. And that is literally that we are not here for 5 minutes, right? So I need to keep you busy for a little bit longer. Let's see what I have in stock for you today. So my personal buzzword agenda for today is we'll be looking at IDP reference architectures, obviously the 5-minute IDP architecture. We'll take a look at SCORE, which has now progressed from where it was, an open source project, into the CNCF sandbox. So it's even more worthwhile to take a look at SCORE. And we take a look at resource definitions, whatever that means. Yeah, as you can see, 5-minute IDP, quicker than a bowl of ramen. Let's see if I can keep the promise. But before we go there, let's take a look at who we are and why we do this. Right, as you can see, lower left-hand side, we are Humanitec. I need to pull this trick because today I'm not wearing a Humanitec shirt. Um, so who are we and why are we doing this? So first of all, we as Humanitec serve platform engineers. And how do we do that? We try to serve them with a build and blend approach. And that means that those components that you see over here that we create and offer to platform engineers, they can be blended into an internal developer platform. And because it's an internal developer platform, you have to build it. That's why it's a build and blend approach. You cannot acquire a complete internal developer platform from the market. That would be a PaaS and not an IDP. So an IDP needs to be built, and we offer components that can be blended into it, most prominently the Platform Orchestrator here. And as I said, SCORE, which is now not really probably our brainchild, but not our possession anymore. It's now in the CNCF sandbox. And marketing makes me show the rest of the slide, but I don't want to dive much more deeper in it. We have awesome processes and we can scale quite well. I am still alive, and that means I'm the living proof that our processes scale quite well. So the question remains, why are we doing this in the first place? And the reason is that most of the time we see a playing field that looks like this. So we start on a few pain points, and some of them come from the developer side. They are usually missing self-service, which means they have to create tickets to actually get to the resources that they need to accompany their application that they are building, like a database, for example. Yeah. Um, and because a ticket is such a nice way to convey information, how that database should look like, I have to actually know quite a lot about that database upfront to actually convey all of the right information in that ticket so that I get the right database built out in the end, which means I earn a lot of cognitive load. Obviously, waiting on tickets is slow and is not a great experience. But that is just the developer side. At the other end of the spectrum or at the other end of the ticket queue are the infra and operations people, right? And they are suffocating in the tickets that come in. Obviously, developers most of the time are quite knowledgeable, but not that knowledgeable in infrastructure configuration. And due to that, there are a lot of insecure configurations coming around. They need to be manually reviewed, which makes the ticket runtimes even slower. And obviously, you end up with a ton of invariants, which means slow standardization. If that sounds a little bit like your place, then don't you worry, you are not alone. It's basically what we see almost anywhere. And we thought to ourselves, what could be the best remedy in this case? And we think that is platform engineering. So if you add a platform to remedy that situation, then you need to look at the key value drivers and who is actually driving them. So we have the DevX or developer experience platform engineers on one side. They are, so to speak, the champions of the developers, and their weapon of choice is automation. Why? Very simple. If you want to get rid of missing self-service, you need to have full automation first, because if anything is not automated, then you still need to have a bio interface, so to speak, a ticket machine, yeah, and you need to wait on that ticket. Only if the process is fully automated, you can really self-serve something. And that's great, yeah, because now you can create those needed resources even faster and fully automatically. But in the end, that leads to the fact that the other side is drowning in possibly a bigger sea of instances created by the robot. And that means on the other side, you have the infrastructure platform engineers, and their weapon of choice is standardization to counter that force created by the automation. And standardization simply means that if I have a very standardized way of creating databases and I only have a few invariants, then I can employ fleet management tactics to actually move them all at once. And through that standardization, I'm able to make this sea of instances manageable nevertheless, although there are quite a few drops in that ocean. I'm getting pulled into something. Yes, the recording will be shared after Nick. Don't you worry. Right. And in the end, if you reach that state and you let those platform engineers do their job, then developers actually get all of what they need in a self-service automated way, which means time to market goes down. Standardization helps with all of the maintenance cost, which means cost goes down, and hopefully innovation gets up, and the managers are happy impaled on top of this pyramid. I have no idea why. So, bird's eye perspective. How does this actually work? Because it all sounds great, right? When you look at the marketing slide, almost anything is a great idea. But how does this work in reality? So, a developer, sleek guy over here, creates an application, defines a workload, and its resource dependencies with score. That part is important because score is a very abstract request. And you will soon see how abstract and why. And that abstract request is forwarded to the platform orchestrator. And the orchestrator is, as the robot in the middle instead of the ticket machine, able to translate this abstract request according to the rules that the platform engineers down here have defined. So how resources are provisioned with resource definitions and criteria specifying where they apply. So that means you could, for example, have one definition on how to create a certain resource in development and another one to create it in staging in a very different way. Because in development, you probably want a scaled down resource that is cheap and fast. In staging, you want something that you can load test already or integration test in the same way like you would test production. So it needs to be a little bit more fleshed out, a little bit more sizable. Doesn't matter because the robot knows how to create the right invariant in each case, which leads to the fact that as soon as the orchestrator has done its job of creating the infrastructure, yeah, it will actually also take any configuration that is needed, like the database connection string, and inject it into the application configuration. And that means as soon as the application is deployed, everything clicks together seamlessly, and the platform has achieved the outcome. So let's take a look at a score file, because that is this abstract request. So as I said, score is now a CNCF project, and it is platform agnostic. That means whatever you see here in this file, it doesn't hint at a specific platform. You can put it in front of any platform. And it is also environment agnostic. So you won't see anything in here that points to development, staging, production. And the reason for that is that it is so abstract. And that means one score file is enough. It is equally useful from development or from local even, where I can use it to deploy onto a local Docker daemon or local Kubernetes cluster, up to production. Yeah. Let's take a look at the important parts. So we are talking about a product service here, and that product service needs a few things in the runtime environment to be able to carry out its destiny. So for example, it needs a DB named DB of type Postgres. It needs a bucket of type S3. and it needs a DNS record because who likes typing IP addresses, right? And the rest is a little bit of plumbing. As you can see, developers can easily take, for example, the outputs generated by that Postgres database here from resources named DB, take the user, password, host, and so on, and turn that into a connection string that is now inside of the runtime environment of the application. So it can simply read it from that nsvar, configure itself, and it will connect to the right database. And that will be equally useful also in every environment, and it will be specific, so you will never connect to the wrong database. That's how SCORE semantically works. A very simple thing, but it is important that it actually stops at this level because that's where developers start caring about infrastructure. That's one thing, why they like it. And on the other hand, it is a clear demarcation line between the developer's job, hey, I need that stuff, and the platform engineer stuff, hey, I tell the orchestrator, and by that, I define how that is actually being created. Yeah. So separation of concerns, separation of jobs, clear demarcation line where who does what and which artifacts belong into which repository. And on the other hand, if you have all of the details missing on that side, you need to fill them in on the other side, on the platform engineer side. And this is a resource definition. Infrastructure and operations teams define the rules through in them how infrastructure is actually being created. So the important parts here are, we're looking at a resource of type Redis, so Redis cache. This is using the Terraform driver. So we are looking at this Terraform module here, which is in Git under revision control. That is being executed as soon as the developer asks for Redis cache under the condition that the environment type is staging. Yeah. So now I know how to create a Redis cache in this case by simply executing this Terraform module. So now the question is, how does the orchestrator handle all of those dependencies and the interrelations? And the simple answer is the orchestrator creates a resource graph from the score file and the resource specs. So in the context of staging, if the type is Postgres, use this resource definition. If the developer has asked for that, and in this case he did, so resources db type Postgres, this definition here is the right one. So CI now builds a container and then projects the score file towards the orchestrator. And usually at that point in time, the information where this should be deployed is conveyed as well. Think of it like this. Developer commits a piece of code into version control. Well, that should go to development. Next thing that happens, developer puts a tag on a specific point in code and demarcates this version as the version that should be the next release candidate. Well, different pipeline is triggered into action, which conveys to the orchestrator, hey, this is going to be the next release candidate. Please promote this point in code to staging. All right, that's what's happening here. So orchestrator figures out how these resources should be constructed and builds a resource graph which carries that information. Yeah, in this case, we have the workload here, which has a very specific image. We have the DNS record up here. I think that's Cloudflare. We have an RDS database, and we have, I don't even know what that is. Whatever. Right. But now, next thing comes around. After the graph has been executed, the developer thinks, okay, that did work well, worked so well, I want a new revision. And now, as depicted on the last slide, he wants to introduce a Redis cache. So add it to the score file, cache type Redis. What happens next is that go through CI again, new image is built. Once again, the orchestrator figures out what the right resource definition would be. And this time it finds out, okay, in staging, Redis cache equates to an elastic cache cluster. Okay, cool. So the resource graph is enhanced through that node. And then the graph is executed once again, because each node knows how it's being constructed. In this case, the Terraform run is executed, creating the elastic cache cluster in AWS. And that's how you end up with the right infrastructure, with the right configuration being passed to the application. So if you think about that, it sounds great, probably solves a lot of problems, but how do you fit that in, that one component? So you can, for the first time, see a platform. We talk about platforms. That's great. And this is one of our reference architectures. As you can see, that cornerstone, the orchestrator sits here in the middle, and it actually orchestrates a few other components to achieve the right outcome. So what is important on that picture and what is not? I don't want to talk you through the whole thing, right? Wanting to talk about the 5-minute IDP today and not so much about the reference architectures, but I want you to see that nevertheless and understand it because that is the next natural progression step up from the 5-minute IDP. Although the 5-minute IDP will have all of the core components, and that's a great question, Benedict. Can the orchestrator work with on-premise systems like vSphere and ESXi? I tend to say yes, depending on what you want to deploy and the orchestrator, right? If it's the orchestrator that Humanitec provides, the Humanitec Platform Orchestrator, then it can actually deploy containers on top of container-enabled vSphere clusters. Yes. Right. Coming back to the picture here. As I said, I don't want to talk you through the whole thing, but it is the next step up. Everything you do for the 5-minute IDP can work-wise later be put into the frame of such a reference architecture, but obviously such a reference architecture cannot run on your notebook anymore, while the 5-minute IDP safely can. Yeah? So you can play around and find out if that is the right thing to have as a component inside your platform. And then you can progress up to one of the reference architectures and you can quickly modify that to be your MVP platform. So how do you modify that reference architecture? Quite easily. You keep the planes, the big boxes, right? They give direction. They give a certain language to give reason in the world, so to speak. And it was quite a journey to get there. And before we had these kind of reference architectures and they got so pervasive, it was really hard to talk about things because we had no common language to, for example, say like, okay, you're talking about this kind of system. Well, that goes into the integration and delivery plane, right? So it was really hard to have a good conversation and actually mean the same things. That is now much more easy. So you keep the planes, they give order and direction. You also keep the boxes because they represent capabilities. And you're most likely not building a platform that has less boxes than the ones you see. Yeah? Probably one that has a lot more boxes, but this is like the least common denominator between all platforming attempts that we have seen. And you're probably not going to cross out a lot of boxes here. What you're going to cross out and exchange easily are the icons, right? You don't like GitHub Actions because you're a Jenkins company. Well, cross out GitHub Actions, put Jenkins in there. You don't like the whole thing because it says AWS on top. Well, pick the reference architecture for the cloud provider of your choice, or the on-prem one, for example, with Red Hat OpenShift, or whatever floats your boat, right? So that's basically how it works and how you can quickly modify this and turn this into an architecture you like more. So, but as you can imagine, setting up that whole thing, it's quite an endeavor. Yeah. So what do you do if you want to be quicker? Well, you probably take the 5-minute IDP. And this is architected quite a bit differently. So usually you start out with your own computer and the cloud. In the cloud, you have the SaaS version of our orchestrator. On your computer, you have Docker daemon. Through Docker, you run a client cluster, so you have Kubernetes to deploy to. That's great. But does it work? Usually not, because as soon as the orchestrator tries to deploy something on top of your client cluster, it will run into a firewall or any kind of networking constraint between the internet and your machine. To get rid of that problem, we have one more component, which is called the agent, which is running on top of the client cluster and allows the orchestrator to reach through a secure tunnel to your client cluster and deploy as it would be able to if it was sitting in the network right next to your machine. And this is the architecture of the 5-minute IDP. Obviously, you're lacking a lot of the things around, like Git repositories and so on and so forth. But you can put them on the table if you want to with a little bit of effort, or you can progress to a reference architecture, which gives you then the full capabilities. Right, but being a little bit more restrictive on the components and the architecture allows us to be really fast, right? So let's see if I can keep my promise and do a 5-minute IDP run. So I have this URL down here, and I'm going to hopefully click on it. Click on it. Can't click on it. I don't know. Then I'm going to copy it. And you can see this is a link to the 5-minute IDP tutorial. And I'm literally not going to do anything special here. I'm going to actually execute the tutorial. So you can trust that I'm not cheating you. HumCTL login. But I have the prerequisites obviously fulfilled already. So HumCTL login. HumCTL is our own CLI tool, which I'm now authenticating. As you can see, I'm sitting in Germany right now in the city of Hilden. Forget that this is my IP address. So authorized. Now my CLI is able to work for the next 24 hours as myself against the orchestrator. I have already exported this. If I go to my 5-minute session directory, you can see I'm using a tool called the-env to pre-populate my environment. So there's a few variables being set here, and I can actually show you my envrc file because there's nothing secret in here. Yeah, my token is actually acquired from the HumCTL login. So there's no secret in here. You can see that my Humanitec org is called clear code. And I'm going to deploy an app called Whale possibly. And I'm not even going to use this cluster, although my kube context is currently set to it. So starting the toolbox, to do that, I just need to copy this command here. And then it's going to fail horribly. Is it? No, that's a first as well. Usually that's the point in time where I find out I did forget to start my Docker daemon. Great. Okay, so that was all it did take. I quickly downloaded the image and started VM on top, or the container on top of the Docker daemon, which now gives me the environment where everything is already pre-collected. I just need to execute this install script. As you can see, that's the next step here. Install the IDP components. And what's happening now is it's actually starting that kind cluster, and then it's running Terraform to create mainly the configuration of the orchestrator on top of my my own tenant. Right, going to change to the same directory, which allows me to use my convenience script to open the orchestrator in the right tenant here, my tenant clear code. And as you can see, there's already an application called 5-minute IDP PQFA. And that's because the Terraform, which is running here, is not only creating infrastructure components like the deployment of the agent on top of my kind cluster, it's also creating the configuration of the orchestrator. We have a Terraform provider, which allows me to simply talk to the orchestrator's API and create configuration using Terraform. Mighty convenient in this case because I have all of the rest of the infrastructure now in the state file and all of the variables as well, which allows me to quickly reuse that information to configure the orchestrator correctly. And in this case, I have this up here. And if I go into my development environment, I can obviously see nothing. Nothing has been deployed here yet. If I take a look at the tutorial, it says deploy a demo workload, one demo. Let's do that and see if that changes the state of nothing has been deployed. So what you can see here is I'm actually using HumCTL in the background to project the score file towards the orchestrator. And that leads to the fact that if I look at the orchestrator now, I can see the deployment coming in. Right. So the hello world workload is not yet running. Now it seems to be good. In the background here we go. So I had a few curls which went 503. Now the one is coming back because the workload is up and running, and it says you can find it here. If I open up a browser to here, I can see why. Great. There's my Hello World application. It is running against the Postgres database on top of my local IDP, my 5-minute IDP. And I think I've not yet reached the 5-minute limit, so I can still show you a little bit of stuff. All right. Which means I can, for example, go ahead and get this score file to you. So that's the score file that has been used to deploy this application. It's the Hello World application. And it is using exactly this image here. So this is the score sample app, which is living as part of the score spec. And you can find the whole thing here, score.dev. And this is the score specifications home. And obviously, if you go to GitHub, then you can find samples. And was it in the samples? I always forget where it is. No, obviously not, because this is the score specification. And I should probably go to score spec, main repo. And in here, I can find quite a few repositories which represent the different score implementations and the spec, and hopefully also the demo. The demo application. Yeah. Not going to hunt it down right now. Do it in a second. As you can see, it's using the same technique. It's extracting the information from the database, and which is being requested here, a DB of type Postgres, and forwarding that into the local environment. And because of that, the demo application can strip it off and can contact the database. So, but where is that database coming from? Well, let's take a look at the configuration of the orchestrator, then we know why. Or I can simply go into my workload and take a look at the dependencies. I can see that there is the DB type Postgres, and the resource definition to fulfill that is the 5-min IDP PQF8 Postgres. Wow, what a horrible name. If I take a look at this resource definition, you can see, okay, my application is using it. Why? Because the application ID is 5-min IDP PQFA, which is the ID of my application. And if I take a look at the configuration, it also looks horrible. So let's go into the edit mode. It's a little bit clearer. I can see that the so-called template driver is being used to write out a stateful set into the deployment stream, which is directly on top of my kind cluster running another pod, which holds the database. And that's the reason why it's so fast. It looks a lot like operators on steroids. Yes, Leroy, you're not completely wrong, but essentially you are still, because this is all happening outside of the Kubernetes cluster. And that's important because an operator can usually influence mainly the world on top of the cluster. Yeah. So what's happening is that the orchestrator is outside of the cluster, preparing the whole world and putting everything into the right state. And it may even use operators by putting custom resources into the deployment stream, and by that triggering operators into work, yeah, and letting their controllers resolve some of the resource requirements, and by that creating the whole thing. Yeah, but if you think about operators, they are usually, as I said, confined to that one cluster. I know that there are others who are taking that paradigm a little bit further and saying, okay, I'm having an operator which is basically controlling a lot of other clusters out there. Yeah, thinking about cluster API here. or who is or that is controlling the outside world. Yeah, but that is literally an edge case. Most operators are not like that. And because of that, they are lacking the cross-cutting concerns, so to speak, that you need to actually have a central orchestration instance that orchestrates a lot of the things outside. Okay. The logic between score and what is created as resource reminds me strongly of the logic of kubevela. Haha, that is not a very wrong statement, Artem. But in the end, kubevela is actually choosing a very different path. Score is by choice confined to one workload, so the service the developer is currently working on, and you define exactly what you need for that. While kubevela and the OAM, the Open Application Model, is looking at the whole application and not only the application, but also the application's lifecycle. That means that configuration file will eat all of the complexity of all of the services which are part of your application, all of the infrastructure which is part of your application and all of its services, and also the logic which life cycles this, for example, through different stages, which means this file is getting really large and really complex. So you need a lot of knowledge to actually understand it. And Score is actually the counterpoint to that. It's trying to be as simple as it can to reduce the cognitive load. And what you need to keep in mind when you as a developer are working on that exact piece of code and leaving the complexity to the people who should be able to handle it, to the platform engineers. Yeah. But the link between the two, as I said, score and what's happening, also a little tiny part of the OAM specification when it's handed over to kubevela, what's happening there, that is then a little bit the same. Yes. That's why we no longer use kubevela. Okay, cool. Thank you for that statement. Um, I have the same beef with kubevela, to be honest. Yeah. Um, Okay, anyways, I wanted to show you a little bit of that. My 5 minutes are now definitely over because I'm already rambling about different things. But this is the 5 minute IDP, right? And I could now go ahead and deploy different things or show you how to create another resource definition so you can get, for example, um, a Redis cache instead of a PostgreSDB, but I leave that to your own exploration or to your invitation for a virtual coffee to me, right? If you want to have more insights into that direction. And I would say we now turn it a little bit more over into open Q&A and see where that takes us. If I didn't completely forget what I'm doing here because I'm just back from vacation and I should totally be going back to my slides and probably going through the rest of the slide deck. See, I already triggered Maria into picture mode again. Awesome.
Welcome back, Clemens, from your vacation.
Right. So to recap that quickly, things we have touched today. So now you know about IDP reference architectures. I think they are a really interesting topic, not only because they allow you to very quickly get to something that you can credibly test end to end and also show to people inside of your org and ask them like, hey, if you would have a few wishes as a developer, would some of them be for something like this, or is that completely in the wrong direction? You can get there so fast. That's interesting. And also the common lingo that they provide, so that when we as professionals in the platform engineering space start to talk about things, then we understand each other. That's a great feat that those reference architectures have achieved for sure. You've seen the 5 minute IDP architecture, which is as simple as it gets to make it, to give it the ability to be very quickly run on top of your own machine while still harnessing the whole power of a platform orchestrator in the background so you can find out what that is all about. You've seen a little bit about score files, which is set now part of the CNCF sandbox. Did I already say it's part of the CNCF sandbox? No. Which is something that was the brand new thing before I went to vacation. So it's still very in my mind. And I like to talk about it. And you've seen at least one resource definition and hopefully now understand while score on the one side is the right abstraction for developers and resource definition on the other side is the right abstraction for platform engineers, because together they actually segregate quite nicely where the work is happening, where the artifacts are landing in the repositories, and both of them allow to decouple the actual implementation from the specification inside of the configuration file. And that means you can evolve that implementation autonomously and in peace, while the robot in the middle cares for the fact that each time a deployment comes rolling along, the actual right version of the then existing standard is being chosen. Right, so let's see Q and hopefully A. If you want to take a spin of the 5-minute on this 5-minute IDP, you can actually use that tiny OL, or you can just scan this QR code over here. If you want to become part of the platform engineering Slack and you did not see the link that Maria posted into chat already, you can use this tiny OL or scan this QR code over here and happily shoot questions at me now.
And you probably expect fireworks, Clemens, no? Or ambulance?
No, questions, just questions. They
Just
will be fine.
nice. What would be the best next step after, like someone tries the 5-minute IDP, kind of like got the idea how it could work for their setup? What do you think is the logical next step if you are on this platform engineering journey?
Well, as I said, the next step would probably be standing up such a reference architecture. They are not just slideware, right? They also come fully open sourced in a terraformed state. So you can pick them and stand them up quite quickly. It should take about an hour or so. But obviously they are attached to quite some cloud cost. So you probably want to experiment a little bit with the 5-minute IDP first and find out if that's the right thing. If so, get a little bit of budget or a free account that has, I don't know, a few $100 of free credits from the cloud provider, and then stand up a reference architecture and see how the thing is behaving in reality end to end with all of the components you have seen on the architecture diagram. And if that feels good, then it's probably the right time to talk to Maria again, or to me, or to anyone you can get from the Humanitec homepage, and start talking about how to get your hands onto the stuff.
True. There is a question from Leroy. Our company uses, for example, a hardware MySQL cluster. Does this also support creating a database and credentials on an already existing database server?
Of course it does, right? You can not only create new instances, you can also share instances, and to be able to share things correctly, you need to be able to create new users with possibly different permission scopes. Like, for example, you have one service who has the admin scope and is able to write into a message queue of a message broker. And then you have a few other services which only have read permissions and can only read from that message queue as the consumers. Or you can have the same pattern for a database, a cache, or whatever, right? And obviously, you have the right primitives to also work with these insides of the infrastructure pieces that you care to work with. MySQL for sure, also MariaDB or Postgres or MS SQL or Oracle even, I think, and so on and so forth.
Nice. There is a question from Joss. How to evolve from a system admin to platform engineering? And probably you know the answer to it, Clemens, like anybody else.
Yes. How do you say that? all sweat, no dreams. Work hard for a few years and you get there. No, just joking. Obviously, you need to get yourself into a learning attitude. But the quickest way possibly is to actually take a peek at the platformengineering.org courses. So there's a new curriculum coming up, which has all of the topics to get you from nowhere to certified platform engineer that has all of the right knowledge to actually start in that domain. Apart from that, there are a few other resources which are definitely recommendable. And one of them would probably be Roadmap. I always forget how that thing is called. Give me a second. Roadmap.sh. Yes. Haha, I remembered correctly. So let me put that into the Slack as well. So that's a pretty cool site which carries actual learning roadmaps for a lot of things. Currently, there's no real platform engineering roadmap there, but there is one for DevOps, and there is one for Kubernetes, and there is one for a lot of things. And to be honest, if you take the intersection of product management, DevOps, SRE, and a few other things, then you probably get slowly but surely towards platform engineering. So that was not what I wanted. Zoom meeting invitation. Wait a moment. Right, if you take a look at the DevOps roadmap here, that is pretty complete. And if you take a look at anything like GitHub Actions, you always get a few articles, videos, a feed to explore more resources. So that's a great roadmap to follow for learning. It's like my personal open source tip. And if you want to get the information fed from the fire hose in a very compact format, then take a look at the Platform Engineering or Fundamentals course.
Yeah, and I added link in the chat so you guys can check that out. Then we have another question. Does Humanitec Orchestrator keeps an image of Docker built image and deploys it into environments? If so, then how do you assure privacy confidentiality of the code?
That's a great question. And the answer is no, it doesn't. The idea here is that a SaaS system like the Platform Orchestrator from Humanitec should never peek into your IP. Right? Your intellectual property should stay securely in your network. So you have your CI system, which usually builds the image and then passes on the right meta information to the orchestrator. So the orchestrator can build out a deployment. And the deployment is then issued to the runtime environment, for example, the Kubernetes cluster. And the Kubernetes cluster will pull the image from the registry. And if the Kubernetes cluster, the registry, the CI system, and the source code repository are all inside of your own network, then nothing ever leaves your own network. Only the meta information, which says, if you know where the image is, you can find it here, which is not accessible from the outside. So even if somebody would break into our orchestrator's data store and get that information, he could not get to your IP.
Cool. Do you need access to Humanitec to use core file feature? Yeah, sorry, Vishesh, I see that you already asked this one.
Yeah, all right. No, you don't. As I said, Score is platform agnostic. It is a code-based interface that we use in front of the Humanitec Platform Orchestrator. There are other interfaces as well. You can get all of the functionality by going through the API, through the UI, if you want to. But developers usually like to use Score as a code-based solution because it can be stored and versioned right where they are working on their code. But as such, it can be used with any platform. Score is open source. It's part of the CNCF sandbox. Check it out. There are different Score implementations which allow you to work directly with Kubernetes, directly with Docker, which allow you to take the same Score file that you use, for example, with our platform orchestrator to deploy into production environments. You can use the same Score file and use those implementations to work against a local Docker daemon. Yeah. for example. But you could take it and put it in front of any platform. And as soon as it joined the CNCF sandbox, we already got signals from quite a few other systems that they are now heavily looking into supporting SCORE as another code-based front end for their system as well.
Cool. Is the orchestrator comparable to other GitOps solutions like Argo CD or Flux?
No, it isn't. It does a lot more than Argo or Flux. Yeah. In the end, you can turn the orchestrator into a GitOps mode, and you can actually write out deployment schematics, which will then be persisted in Git. Then you can take the GitOps operator of your choice, like Argo or Flux, to project those towards a cluster, and then let the needed operators work on turning those CRDs into the actual deployment, which would be our own operator, and also a few others, which then work in orchestration to actually create a deployment. But everything the orchestrator does before to figure out what the right target is, what the right configuration would be in the context, the actual dynamic configuration management, which is the pattern which is happening behind, all of that is something that Argo or Flux wouldn't be able to do because they have a different scope. They rather work on more finalized outcomes and leave you, the developer or whoever is tasked to build that, to define the world before they take over and then carry out the deployment.
Yeah, makes sense. And another question, we see a lot of, I would say, some platform engineering teams, right, like that are saying they're doing platform engineering and building a platform, and in the end, they're just, like putting Backstage or any other portal on top of it and say, okay, done. But is this, like, what do you see? Like, is this the right approach, or in the end, it's just essentially not going to go anywhere?
That's a trick question, right? Didn't sound so great.
Mm.
No, and the answer is pretty simple. If you look at any architecture out there, you will be able to identify discrete layers usually. And probably I can quickly jump back to that one. Here we go. We've seen that reference architecture already. And side here, you've seen a portal layer up here, and that belongs to the front end or the developer control plane. And you've seen there's the integration delivery plane or the back end of the platform where the orchestrator lives. Yeah, and these layers, we usually talk about layer cakes, right? And as we know, every cake only tastes as deliciously as it can if all of the layers are present. Right? So this is literally a better together story. If you have the right backend here, where you have a lot of capabilities, then it's great to have a front end on top, which exposes those capabilities in a nice uniform way. But if you are just having the front end, like a Backstage portal, for example, and you do not have the right backend capabilities to go along, it's like building out a store that has a lot of shelves in it, but they are empty. It's not a great shopping experience if you can't buy products, right? So if you think of this, the portal is like the great sales display, the shelves, yeah. But you need to have the actual products, which are the capabilities of the platform, which go in the backend, come from the backend. You need to have them for sure, or your developers will not like the situation. Let's put it like this. It's a better together story. Do not do one without the other. And I would always say start from the back end first, because we usually tend to prioritize something that shows we are actually doing something and we have something available. And most of the time, we do not prioritize the people who are actually paying the thing, so to speak. So we are not prioritizing the developers who need the platform to achieve the job, but we are rather building out something that looks like a fancy dashboard. So we can show that to a manager and say, look, I have actually achieved something already. to build out a little bit of credibility and get the time to build out the real features. But it's better to do it the other way around. First, build out the features that developers can use in their day-to-day that actually moves the needle and gives you the people from the base that say, hey, we need this platform because it is actually making our job much more easy and we are actually saving money. And that's actually, in the end, the better way to convince the management to push the project even further.
Yeah, makes sense. Does your platform also expand to the life cycle of the application, setting up repos, aim project, etc.?
The orchestrator currently has no scaffolding capabilities. Yeah, so because we see scaffolding frameworks out there, we see that as a functionality that every portal brings along, and we try not to invent the world again there, because scaffolding frameworks actually only are great if they are able to touch a lot of things. So it's not a hard job for you to configure them, and it would be hard for us to establish the next standard. So we don't do that. We expect you to use a scaffolding framework that is already established as a standard, like Cookie Cutter, for example, and build that as another part or blend that as another part into the platform that you're building. And then you have the same capability.
Mm.
Oh, that's new. Now even my phone starts ringing. Jeez. Shut up.
On the development environment, we often use a simplified version of some services, for example, cache. In production, we use Redis. On local, we use a file system due to complexity. Does the score file has support for this, or is there another approach there?
I would say the score file. That's an interesting question. Let me put my head around this. I know how I want to respond, but let's see if I can get real clarity in there. The score file by nature is very abstract, and you only ever have one. So as a developer, you would write in there, I would like to have a cache. And then depending on the context, let's say my context is local, I need to translate this score file into the right infrastructure. And depending if the context is, let's say, production, I need another translation method to translate the score files asked into the right infrastructure. Let's say in production, you're doing this with the orchestrator. The orchestrator picks that score file up, reads, hey, I would like to have a cache, looks into its configuration store and finds the resource definition for production, which says, if somebody asks for a cache in production, please execute this Terraform module, which stands up a Redis enterprise cluster. Yeah? Boom, here you go. You have your Redis enterprise cache. Locally, you want something else to happen. So how does that work? Let's say you want to deploy to Docker. So you use score compose to translate the score file into a Docker compose file. And score compose, as its implementation, also has so-called resource provisioners. So it understands that as soon as the developer has written in there, I would like to have a cache, it should now turn that into something that is a cache. Locally, something will happen that it actually will be a Redis as well in the default, because there is a default provisioner for Redis, which will just create another container inside of your Docker Compose file that will run a Redis cache. For sure, not a Redis enterprise cluster like full-featured instance, just a simple container running a Redis cache. Yeah, so you would have that difference. Or you could go ahead and write your own resource provisioner, which then answers to the question cache with just a local file system and basically delivers back the path to the application. The question is just in those cases, how will the application handle locally that file path while in production it's suddenly a Redis cache? That's a wildly different implementation from the interface. Yeah, so that's the reason why we usually say developers require a specific interface. and that's usually the type of resource they require. It's say DB of type Postgres or cache of type Redis. And the great thing is that you're most of the time setting up infrastructure is a complex task. That's the reason why you see those local cache directories, because developers don't want to find out how to locally run a Redis cache. But using Score and the platform team actually helping them out with those resource provisioners, which can then translate that ask for Redis cache into an actual Redis cache, you can actually drop that complexity of caring for two interface types. Yeah. Uses drivers with URI and path on our end. Files are used, memcached. Yeah, if you have an abstraction inside of the software that cares for that complexity, then yes, it can work like that. But you're essentially trying to care for that complexity then as part of your application architecture. Instead of saying, okay, I'm making my developer's job as easy as it gets, so he doesn't need to actually dissect this driver into this URI, into the type of resource he's dealing with. He doesn't need to deal with different frameworks and implementations on how to deal with the different drivers. Yeah, he just can drop all of that complexity. He can always work with Redis, and the platform or the local implementation cares for the fact that the right infrastructure is delivered. Then that makes the developer's life easier. And the thing is, you need to take into account what the effects of scale are and where they are coming from. Yeah? If you're doing this for one application, it's probably not sounding like a lot of overhead. You're just doing a few more frameworks, a little bit more architecture, and then that's good. But if you're doing that for 100 or 1,000 applications, then the overhead you're projecting there suddenly gets significant. While it would be much more easy to solve that problem once on the platform side and then deliver that capability to all of those applications, which in turn, through the standardization, nets to not only a much more simplified architecture, it turns to savings in the implementation and for sure to savings in the maintenance. And of course, if ever a technology gets deprecated, inside of that stack that you have a few thousand times out there, it's a lot harder to actually deprecate that technology than just to say, okay, on the platform side, I do a central solution, I redo the solution, I roll it out to all of the applications because the interface doesn't change and I'm done already. So technical debt is also a thing that rolls into these considerations when you think of it from an overarching enterprise architecture perspective. Make sense?
Yeah, and there is Benedict who is asking if you're going to be at Container Days in Hamburg, beginning of September. I think it's
Actually,
an invitation for you to Clemens to travel to Hamburg.
I don't know, Maria, if you get me tickets, I'll go to Hamburg. Currently, it's not planned, but actually, I would love to because I know quite a few people who are going there. I just need to somehow find the time for that. And it's a crazy time because my kids are all joining new schools. We have our own offsite, which is happening somewhere around that time, if I remember correctly. And there's a ton of other things happening at the start of September. So it's a little bit crowded. I don't know, Maria, if you find a few bucks, I'll make it anyway. Currently, I don't know of any one from Humanitec who's live in Hamburg.
Yeah, unfortunately, we won't be there, but we are going to be in Berlin, I think, beginning of September at CO Navigate, if you're planning to attend that. Also, this is right before our offsite. And then there is going to be a special platform engineering roundtable with our CEO, Kasper, in Nuremberg. So I know it's probably not very close, but just giving you some stuff that's going to happen in Germany in September. But yeah, I think we're a little bit over with our session. So thank you so much to everyone who stayed in and was active. Hope it was helpful. We're going to follow up and share the recording and slides. So as promised, you'll have that handy. If you have any questions, let us know. And yeah, let us know. Especially, it's always good to hear feedback. How was the session? If there is something else you would like to see, also you can drop the message to Clemens on Slack, or just I'm sure that I sent you one of the emails, so you can just respond to that. But with that, I hope everyone has a great end of the day. Thank you, Clemens, for coming back from your vacation into working mode and driving this session. And yeah, I guess we'll see each other either at the next sessions or at one of the in-person events. It seems this autumn will be very, very busy with all the events around.
Yes, and thank you very much, Maria, for being such a wonderful host again. And thank you, everybody, for spending some time with me and listening to my ramblings. I wish you a wonderful evening. And yeah, hope to see you soon, either for virtual or real coffee. Who knows?
Perfect.
Have a great evening.
Thank you.
Bye, everybody.